with absolute value, if I said, hey, what's the absolute value of 5? What would you guys say that is? Right. What's the absolute value of negative 5? 5. So you're saying that two different equations can give you the same answer. You know what I'm saying? So we got to deal with two different things here. So I'm going to come back to this in a second. But I want us to take a peek at this first one. When you got an absolute value equation, we have to have two different setups. Meaning, the first one is always what you were given. X minus 2 is less than or equal to 3. Notice I just took my exact equation and I said bars. I'm getting rid of you. Bye-bye bars. But then your second equation has to be, again, x minus 2. But you've got to flip that sign and make that it was less than or equal to. So I'm going to make it greater than or equal to. And then that 3 was positive, and I need to make it negative. So we're always going to have two different equations when we've got an absolute value bar. Are you down with that? The first one is just the original with no bars. The second one is always flipped inequality sign, change the sign of the answer. Can we do that? Maybe, do you guys have these cute little arrows on there too? Because the arrows will help us remember what we got to do. Oh yeah, my 3 has to become negative. Whew! Maybe the first part doesn't get the bars. You know what I'm saying? Maybe this guy doesn't get, I'm sorry, an arrow. Because the first part's just the same. X minus 2 is always going to stay the same. Whatever's in the bars stays the same. The inequality sign changes. And the 3 has to change signs. Let's go solve them. How would I solve for x on this one? X would have to be less than or equal to 5. I got that by adding 2 to both sides. What about my x over here? Greater than or equal to -1. So here's the deal. We're saying as long as my answers are less than 5 but bigger than -1, this is going to be a true statement. Here's this cute little thing that I came up with though. A greater than sign and a less than sign. If they're either of these, greater than or equal to, less than or equal to. Okay. It's going to dictate what word goes with it. Meaning, what do we start with here? We've got x minus 2 is less than 3, right? That means that we can say less than. This and is important versus this or. And what this means is that my answers, my x values have to be less than 5 and greater than -1 to make this a true statement. Give me a number that is less than 5 as well as greater than -1. 2 or 4. I'm going to plug in a 4. If x is 4, what's 4 minus 2? 2. Absolute value of 2? 2 is 2 less than or equal to 3? Yes. So anything within those bounds would make this a true statement. So they're answers. Here's how we write ands. So this is an and because it was a less than sign. How we write the answer is you always do the smallest number on the left, -1, the bigger number on the right, 5, the variable in between, and then they're always matching less than or equal to signs. And you're like, how did she know that? Because when you read that, this is saying my x has to be greater than or equal to -1, which is right here, and my x's have to be less than or equal to 5. I can only write it this way when it's an and equation. We got to combine them, letting them know that the values are always going to be in between. How does this one look a little different than this setup? You guys, in order to set up our two equations, you got to get the absolute value bars by themselves first. So before we can do anything on this little guy, we got to add 3. Let's go add 3. So we'd have my absolute value of 4x minus 2 is greater than or equal to how much? 21. Now that my absolute value is by itself, now I can create my two equations. We've got 4x minus 2 is greater than or equal to 21. That first one, nothing changes. In the second one, my 4x minus 2 stays the same. My inequality sign must change. And my 21 also must change to be a -21. We down with that step? Then we just go solve them like normal. I'd add 2. And I would divide by 4. And it might be an ugly fraction. And I'm just going to leave it as 23/4. Adding 2, dividing by 4, I get a -19/4. Based on this original, you can only do my fancy little word game from when my absolute value is on the left by itself. So now that in this one, when the absolute value is on the left by itself, what symbol is that? This is a what symbol? Great. Since you just said greater than, This is not going to be an and, this is going to be an or. This is a greater than sign. So when things are or, you're going to say, hey, my x is going to be greater than 23 thirds or less than negative 19 fourths. You're like, what does that even mean? You don't have to draw this, you guys, but if I were to put these numbers on a number line, negative 19 fourths and 23 fourths, this is saying as long as my numbers are bigger than that or less than that, they'll make this a true statement. Give me a number that's less than negative 19 fourths. Negative 10. If I put a negative 10 in here, what's it? 4 times negative 10? Negative 40 minus 2. Negative 42 absolute valued. 42 minus 3. Is 39 greater than or equal to 18? Yes. What if I chose something bigger than 23 fourths? And if you're like, I don't know what that is, choose something huge. 100. You know what I mean? Let's choose 100. What's 4 times 100? 400 minus 2. 398 minus absolute value is still 398. 398 minus 3, will that be bigger than 18? Yes. So an or is saying that there could be 2 different regions that make this a true statement. And means, there's only one little region. It's got to be bigger than that, but smaller than that. One little region in between. Sound good? Aight. Let's keep going. My absolute value bars. I always want them by themselves, and I want them written first. Let's go move my 3 first on this one. So if I add 3, you agree I've got 4 is less than that absolute value. My cute little trick only works when that absolute value is written first. So I'm going to rewrite that as x plus 1 is what to 4? Yeah, it was less than written in blue. So then I got to flip it just to get my absolute value first. Then what symbol is this? Less than or greater than? This is a greater than, so I know it's going to be an and. Notice that I couldn't have done it from up here because that was a less than sign. Nope, can't do it from up there because my absolute value wasn't alone and by itself. All right, let's set up our 2 equations, y'all. Let's set them up. We got x plus 1 is greater than 4. We always start with what? The first one is the same thing as the first. Just get rid of the absolute value bars. Then we got and x plus 1 is what to what? What's my symbol going to turn into? Less than a negative 4. Love it. Bandy, you down with that? Great. We're going to solve and we're going to get x is greater than 3. X is less than negative 5. And it's an and. Is there a number? If I were to look on a number line. Did I do that right? Did I mess up? Oh my gosh. What a doofus. Why did I say that? Why did I say that? Were you guys wondering? Bandy, I even said, are you good with that?
I was just following.
Obviously, I was following myself too. You guys, I'm so sorry. This is what symbol? Great or a greater than sign, right? Greater, great or. Bandy, I'm so sorry. Parker, were you thinking it?
No.
Oh, okay. An or, if it's saying less than negative 5 or greater than 3, could we have a number be one or the other? Whoo! What a doofus. Sorry about that, you guys. We cannot write this one all fancy because, meaning when I say fancy, I couldn't put it like this. X is less than negative 5 or greater than, because when you do that, that's signifying it's in between. But less than negative 5 is this way. Greater than 3 is that way. So we don't write it fancy. What are we going to do first on this one, you guys? Add 5. So we got to add 5. So we'd get a 9 over here. Then, in order to use my shortcut, we got to put that absolute value first. So I'm going to say absolute value of x minus 2 is less than 9. Can I do this correctly this time? Less than. And or. Yeah, less than. So this is going to be an and. Did I really do that right this time? Sheesh. First equation stays the same. We got x minus 2 is less than 9. And then we got x minus 2 is, flip it, greater. Change the sign, negative 9. Cool. All right. We're going to add 2. So x is less than 11. and x is greater than -7. Thanks, Bandy. When it's an and, you guys, you always put the variable in the middle. You put the bigger number on the right, the smaller number on the left. Then my signs will always be less than signs. Always. They will always match. Because this is saying my x's are bigger than -7, boop, boop, and my x's are less than 11. Parky, can you give me a number that would fit that requirement? Less than 11, but bigger than -7.
2.
2. You guys, what's 2 minus 2? 0. Absolute value is 0 minus 5. -5. Is 4 bigger than a -5? Yeah, you found the good region. One more, peeps. See if I can do it without making a mistake. Here we go. Ooh, what do we got to do first on this one? Add 3x. So I got 3x plus 4 is greater than or equal to 3x. Guys, don't let that x scare you. We do exactly the same thing. We're going to bring the first one down. Everything stays the same. Don't let that 3x scare you. On the next one, 3x plus 4, what would we do with that inequality sign? Flip it. What would I do to my 3x? Yeah. Let's go solve. What the heck? If I subtract 3x, what do we have? 4 is greater than or equal to 0. Is that a true statement? That's a true statement. So that kind of means like infinite solutions right now. When they're true, we're good with it. What about when I subtract 3x over here? 4 is less than or equal to -6x? Ooh, what happens when I divide by a negative? Yeah, that symbol has to flip again. Lots of flipping symbols. 4 over -6 would simplify to -2/3. So, let's see if I can do this right. This symbol here, not what we started with, but when my absolute value is by itself and in the front. What symbol? Greater or less than? Greater means a or. You guys, here, when my 4 is greater than 0, that's a true statement. That right there means infinite solutions, meaning you could pick any x value and plug it in and it should make a true statement. So it's saying anything would work. That's an infinity sign, even though it's ugly. Or my x's have to be less than -2/3. Bandy, if we're saying infinite solutions or my x's could be less than -2/3, I don't want you to pick one that's less than -2/3. Give me a number that's not less than -2/3 because that would meet this requirement, and let's see if it works. Give me
7.
7 is any number, right? It also doesn't meet this requirement. Let's do it. Guys, what's 3 times 7? 21 plus 4. 25 absolute value is 25 minus 3 times 7. You chose a 7 there. 3 times 7 is 21. What's 25 minus 21? 4. Is 4 bigger than 0? So this works or that works. Is there one that's more ambiguous? If it could be anything, do we really need to put this restraint to it? If it could be anything or x's are less than -2/3, the final answer, you guys, would technically just be infinite solutions because that encompasses this work as well. Does that make sense?